opening ceremony and the presentations. So I will try my best to be as quick as I can. Okay. So this talk is going to be covering a very wide topic, that's malware. Malware itself is a very broad category. So the specific category which we are going to target in this keynote is the scripting malware. And when it comes to scripting, we are going to see how a particular scripting language, the VBA, that's we're going to use as a test case to see how we perform machine learning on that. Before I get into the talk itself, this work would not have been possible without the amazing team. You can see them over here, if the pointer works. Okay. Okay. Yeah. Do I need to do anything? Clicker is this one. Yeah, so we're going to speak about scripting. Shinlai, Ling, Timothy, and myself, we took initiative of this project as part of our Innovation Day. We don't call it hackathon for very obvious reasons. We don't use the word hack for very obvious reasons. So, this is the Innovation Day. So we got through the Innovation Day and the Innovation Den, and we end up productionizing our solution. Let's go further into machine learning at Symantec. So machine learning had been with Symantec for a really long time. I think we were the early adopters of machine learning. We have been using it so we have a very special and very powerful, really, the brainy people out there in Semantic Research Lab. We have a Center for Advanced Machine Learning as well. What these guys are doing, they are building models and building solutions, how to stop spam, how to stop malware, how to identify spam, how to categorize spam, and it in fact help us to compound the impact of our detection. It's needless to say here is that Symantec is in the front line of when it comes to adversaries and their attacks, whether they are state actors, individuals, people doing that for fun, people doing that for just testing the system. So the challenge with malware is its polymorphism. So malware, when it reaches the destination, it tries its best to be not detected, and the way it can do that, it changes its behavior, it changes its piece of code. So this is the whole the lifeline of the malware. So it starts from incursion, infection, and then so we have like different solutions at different point in time. So once you get infected, there is a different triggers that happen on the product level. Once the infection is there and it's trying to reach out to the command and control system, which we call CNC, there are different products and components of the product, semantic endpoint, which actually helps defend against that. And at the end of the day, what's the most challenging part is that once you deal with one part of malware, it's not the end of the story. It's just that it's people, the adversaries, they come with variants of that, and that's a bigger challenge. So it's like we have to keep pace with these challenges coming towards us. So eventually, how at the end of the day, how we do get infected, the answer is lies into the carrier of the malware. To this day, we'll see the stats as well. To this day, the most common and most widely used carrier for delivering a malware is the email itself. Even though we have social network messengers, we have social network, messenger, SMS, iMessages, everything, but still email is we have app stores, but still email is the widest used medium for delivering a malware. 1 in 131 email, as of now, it has a malicious link. or an attachment, and that's the fact. And this increased from 1 into 20. So I think it was like 2 years back. It was in 1 into 20. So it's not stopping. The SMEs, so 1 in 95 emails they receive, the SME, the small businesses, they receive, because they are new. The system and practices, best practices may not be there, so they are targeted a lot. Email, the frequency of email is 269 billion. That's the stat for 2016. We'll see the forecast of the emails also, where it is heading. The general worker, for the average worker, receives 600 emails per week. There's a reference for that. The people actually track the emails received by general worker. And one interesting thing is that email serves as a blended medium of attack. So it can be a malicious URL, or it can be a malicious attachment. A URL can lead to a download. A URL can redirect you 10 times, 5 times, 6 times to download a particular file, and then you can eventually get infected. Your machine will get infected. Office documents are a very effective way of delivering a malware, because they not only carry the text with them, they not only carry the content with them, but they also carry the Visual Basic for application code behind them. And it's a very light footprint. They can obfuscate behind the Word document, and we will see how one of the hospitals in Hollywood, they were attacked by a ransomware which was sent to them in just plain attachment, and they ended up paying a really good amount of money to get their data back. So if you see here, this is the worldwide traffic of email. It's in billions. So right now we are somewhere over here, and it's increasing pretty consistently. And worldwide email users, that's also increasing. It's pretty consistently. This email, the interesting thing about this email is that it was sent to the sender. And if you look at this attachment over here, when you open this attachment, you will get this thing. So a naive user will see this, and what eventually you will do is you will click options, and once you click enable macro if data encoding is correct, there's a checkbox for that. Once you do that, this script will communicate with the command and control system and download a malware and encrypt all of your particular extension files. Sadly, one of the affectees for this malware, Lockheed malware, was a hospital in Hollywood. So how eventually the malware looks like? So this is what we have seen so far is the cover, how they hide behind the curtain. What's behind them? So we will see how the people have been writing malwares. If you see here, they are using a random variable with a string split. Can anyone identify what's wrong with this script? It's actually this thing. So if you are looking for a PowerShell command, right? So the adversary, he kept a split between power and R shell. That's a very, very primitive way of doing that. Not only this, but we will see that it's a window style, so it's trying to invoke a window with a hidden attribute. So you'll never know that whether a window had been opened or not. Also, it's something to do with the web client, right? And of course, on top of that, we have WS script shell. Next. We have a lot of fake things in this. We'll see what are those. Too many variable declarations, right? A redundant comment, making no sense. Rem is a VBA command. I think goes back to the basic itself, but is commented, and also this comment. And there is no particular, there is no use for this condition. 167 will never be equal to 160, right? So yeah, let's see some more examples. Multiple function. So in this example, we'll see that there are multiple function splits. This hash function is this function. So this is the in VB. If you assign the name of the function to the value, it means that you are returning this thing. So if you see that this, there is C missing here, right? So this is client. So C should eventually be a part of this, this sample. You see more. This function and this function. What's the purpose of this function? Nothing. It's not even a space over here, right? Let's see one more. This function and this function. It is just concatenating H. So wherever it will be, it will be concatenated, and the ending string will come up. We will see that C will come. C will be where it has to be, and this and H will be concatenated with the ending string. Let's see some more. What does this look like? This means this looks like they're trying to construct a URL with an argument, right? This is really, really interesting. So if you look at this string encryption, a lot of effort have been made in this code to encrypt the string. And not only that, but they are calling functions with a variable argument, variable length, variable number of arguments, and using a lot of random variables. See? Yeah. This method, it is a multi-function. So you see, it's trying to invoke with a U, and this function is called from here, and you see it's concatenating it whatever the output of this function, right? So you can see that the challenge to is the set of challenges faced when dealing with this type of code, and this as well. So this is an interesting bit, because at the end they are invoking a shell. So shell means that you're trying to run something in the command prompt. And why would you do that? I mean, if you are in a Word document or an Excel document, there shouldn't be much of a need to go into the command prompt. I guess this should be the last example. Control tip text. It's hiding a string on the user control behind a control tooltip text. It's a very intelligent way of doing that. And ID is D will always be false. See, and there is no point of having this condition over here. But eventually, it's there is an object. This object is being called. Object has been created and assigned to this variable. So what we saw so far is that we are faced with a challenge of dealing with the data, which is a handwritten text. So what's the first thing which comes into mind is that we have domains for dealing with handwritten text, and those domains are programming languages, which we see here, and natural languages, though they are very, very different from each other. Ambiguous, we have context in the natural languages, whereas in programming languages we have a very clear distinction between the syntax and the semantics. What's the syntax? It actually means the semantic. And in the previous examples, what we saw is that they were trying to mess with syntax, right, to obfuscate the semantic. So this is the theme which the adversaries they try to do, is that they obfuscate the code the execution of the syntax will, the execution of the code itself will remain the same, but the semantics will also remain the same. What they try to play with is the syntax, so that they try to distance the syntax from the semantic, which eventually is not the case, but they try to do that. We have very clear comments, conventions, and design patterns in identifier, subroutines, calls. On the other hand, in natural language, we see rands, parodies, imitations, TF-IDFs. We can see things like this in comments in the code, but that's not the case with our problem. So in recent days, I think one of the research which I found very interesting is this paper from MIT. They proposed, I think they demonstrated that they can run machine learning model on a piece of code, and they can generate automatic patching of the code. This is quite an interesting paper, and this is one of the efforts which says that it's going towards handling code in the context of machine learning. And this leads to a very interesting notion which comes from the industry and comes from the security industry also, is that how we make use of immense telemetry which we have, immense signatures which we have, and how we can utilize them. There comes in the concept of human intelligence, and with human intelligence, with human verdicts, and the analysts creating rules and giving samples their verdicts, we can build on top of that and take all the attributes of the code and send it through our machine learning model. And this is I think this is fundamental to our approach, is that we not only make use of the automated feature extraction and manipulation, but also we use the features tagged by the analyst. One of the things which how eventually we ended up doing is that we extract the artifacts from the piece of code, and then we do rigorous feature engineering. And at the end of the day, what we do is that we have when the email is received. Okay, yeah. So I think this. So I think there's something wrong with this. So the email is received over here. We match it with the hash if the attachment is already seen. So this leads to a very interesting observation, is that would you be doing machine learning on an already seen hash, which is very, very destructive? For instance, if a Stuxnet hash comes towards you, what you would be doing? Would you be sending it to your model to get you the verdict, or would you just stop it? I think the latter is the solution. We just have to stop. If there is a hash match, bang, we drop the sample. We don't deliver it. But if it is not, then take the features out. For instance, if the VBA Excel file, see how many objects are there, how many go-to statements are there, how many blank lines are there. Just a few of the samples which we look into. How many library functions are called? What are the methods and keywords? What are the total number of lines? What's the size of the module? How many modules are used in the code itself? How many VBA forms are there? And all of these details. So we feed all of these features into the model, and what we get is a match, and eventually, this is how our features look like. So this is already obfuscated. so I'm not giving out the features which we look into, but we expand on individual features as well. For instance, if there are calls to a library function, if there are calls to a PowerShell functions, so we actually expand on that. In a way, we make the code more atomic. So the more atomic it is, the more information we have about the code. And later, of course, when we do feature engineering, we have to treat the composite variables, the dependent variables, and the singleton variables, because eventually they will impact the performance of not only your model but also your match. So this is how we got rid of the categorical features, we got rid of the composite features, and we found that our performance of running of the model was increased by 80%. So after doing all of this, I will show you the real results, actually very recent results up to this day. So one of the findings which we got is there was a spam run between 21st and 27th of August. So this is how it looks like, something similar to this. And we managed to capture a sample which was trying to execute a shell command with an explorer in it. And there was some further artifacts for this command also. Another set of findings which we got is this one. I think this is up till this morning. So there was this not only spam run, but so there are like tailwinds for the spam run. So once the spam run is over, it actually it doesn't subside immediately. So this is followed by the spam run, and we saw that we managed to stop this email sample with this artifact. If you can see over here is that it's trying to do string manipulation, and over here we see that it's trying to invoke a shell with a run. Not only this, but it's invoking and concatenating an obfuscated object creation shell and run command in one. That's a pretty well written code for the malware. We see over here is that so this is the name of the object. You can make so they're trying to obfuscate the name of the object, and then they create the object. Over here, they create the object with obfuscated arguments. Not only this, they have assignment variables which are again obfuscated. This is also we managed to capture is the macro with constant manipulation in the function call. If you can see here that it's trying to get the indexes of a string variable. See? Highly random long string, object creation, and random subroutine name. Again, in this one, what we see is that with again suspicious assignment, shell safe to file a string with this variable name. So within this string, they're trying to save a file. They're trying to save a file with a variable name with a string in it, and this is the name of the variable. Sorry, this is the name of the file which is being created and run immediately after the malware is run eventually. So, and of course we captured a lot more artifacts like that. So what are the things which we see over here is that if an artifact is missing, means a sample is missed. That's not the case anymore, because we are looking at all artifacts in unison. So that actually helps us to not to slip any of the artifact away. If there is an obfuscated function call, if there is a shell call, if there is an explorer call, that would not be missed in this case. Obfuscation will always remain a challenge, and it's not going anywhere, and it helps us stay employed. So yeah, so I think it will remain to be one of the very challenging aspects of the malware identification. For one of the examples of obfuscations is the identification of why would a string variable, as an example, why would a string variable be assigned to a byte array? It can be a legitimate assignment, but that we have to find, that we have to take note of in the malware identification also. Similarly, why an assignment expression, we actually have seen cases like this, why an assignment expression is a 200 character long. In normal programming and development, you would prefer not to do things like this. And so the better we get at this, it will help us to move the malware, the running of the actual malware in the sandbox environment from the sandbox environment to the static analysis. So what happens is that if we are unable to identify the malware from statically, then we have to make it run, and we have to do that that's a very known technique in security. You have to inflate the malware, see what are the changes. Sometimes you have to do sandbox comparisons from a normal sandbox which doesn't have the malware run on it, and an infected sandbox. And this leads to the conclusion of my talk. Thank you. Thanks for staying this long. Thank you.